Hello everyone, welcome back to another MDL workshop. My name is Adrian. Today we are going to be looking at how to do some advanced plastic part modeling. We're going to be making a box with some more curved edges, something a bit less, I don't want to say less boxy than we usually make, but less sharp edges than what we're used to, and how to make some bit more irregular shapes. And at the end I'm going to show you a bit more of how you can design in order to 3D print something. So let's just dive right into it. So as per usual, I'm going to start with a new part. I'm going to go standard millimeter.ipt. Just if you get this stupid pop-up as per usual, just tell it to go away. The same process as always. Now we get our standard workspace as per usual. Now today I want to be able to make a box sort of with one shape on the bottom of it and a different shape on the top, and I'm going to connect those two different shapes using this tool right here called the Loft Tool. Now if you can read this sort of mini little image here, it basically, you can see they've got this oval shape on the bottom, and they've got this oval shape on the bottom face here, and if you want, you can see sort of where the cursor from that screenshot is taken. They've got another little shape up there, and you can sort of see how these two shapes are connected through this object. Now you can use lofts in a variety of ways. I'm going to show you the simplest way today. So let's just go ahead and start. Now, in order to make a loft, I need at least 2 sketches. You can see here between 2 or more sketches in the description. So I'm going to go ahead and start with my first sketch. Start 2D sketch. I'm going to sketch on the XZ plane today because I feel like more of a bottom-up approach is necessary here. So I'm going to make my standard sketch here. I'm going to start out, I'm going to use a 2-point center rectangle tool. You can find that just under the drop down here. With my 2-point center rectangle tool, I'm going to select the origin here, which is the green dot that will appear. I'm going to click, and I'm just going to drag my mouse out a bit farther, and the dimensions I'm going to give this rectangle are a height of 90 millimeters. Press tab, and I'm going to give it a width of 140 millimeters. Once we're done, it should look something like this. Now, I'm not gonna exit the shape right away. I'm gonna do a bit more sketching because this seems a bit lackluster. Now, if I wanted to, so I'm gonna try and design a box today, right? And typically, when you're designing anything that's meant to be used, you really don't want any sharp edges like this. No sharp corners. It's more important for stuff that's made out of metal. But for this case, I just wanna go over some good design principles. So I'm going to go up here to the Fillet tool, still under a sketch tool. We're still under sketching. If you accidentally exit your sketch, just go back onto the model tree here, double click it so you can go back into sketch mode. I'm going to click on Chamfer Tool here, and I'm going to set my chamfer distance as 8 millimeters. Keep it on the first setting here, and I'm just going to add some chamfers to each corner. So you can do that just by clicking the lines you want to create the chamfers between, just comme ça. So I'm selecting here on the bottom right here, I'm going to select the rightmost line, and then I'm going to select the bottom line, and it should just make these automatically. It'll make these little dimensions for you, FX8. I'm going to do that on every single corner, and I'm just going to click OK. Now, this is still pretty a boring shape, but I'm going to leave it like this for now. I'm going to click Finish Sketch. Now, I have one sketch, and according to the Loft tool, I need at least 2. So I'm going to consider this sketch that I've just made as the bottom of the box. So now let's say I want to make the top of the box. So I'm going to make a new sketch on a different plane. So if I'm considering this to be the bottom of the box, and let's say I want the box to be 30 millimeters in height, I'm going to go over here under the work features and the ribbon at the top. Just click the drop down on the plane. Select offset from plane, and we're just going to go under the origin here. I'm going to select the plane that I made my sketch on. In this case, it's the XZ plane. If you used a different plane, you'll just want to line it up with the sketch you've made. So I'm going to select the XZ plane, and you'll see it gives me an arrow of how I want to offset my plane from this sketch. In this case, I want the height of the box to be 30 millimeters, so I'm going to type in 30 millimeters. Bam. And as you can see, we now have a plane that is 30 millimeters offset from our sketch. So basically, I'm going to use the Loft tool to connect the sketch on this plane and the sketch that we're about to make on this next plane. So let's just go ahead and make our sketch without further ado. It's going to be another rectangle, this time 80 millimeters in height, 80 millimeters in height, and 90 millimeters in the width. And there we go, we've got another rectangle on the inside. And like I said earlier, I don't like making rectangles with sharp edges very much. So I'm going, this time, just to change it up, I could use a chamfer again, but just to change it up, I'm going to use the fillet. So you might find that it is easier when you're designing, you might find that it's actually easier if you know you're going to apply fillets to some sort of shapes, fillets or chamfers to any sort of shapes. It might be easier to actually just do those within the sketch, because due to how all the features build up in your model tree here, you will have to wait until the very end if you're going to use a feature, so like a 3D modeling version of the fillet or the chamfer. I can explain that a bit later. So I'm going to make 10 millimeter radius fillets, and you can see I just made my first one here, 10 millimeters. It just does the same thing as a three-dimensional fillet, except it's just a two-dimensional space. So I'm just curving off these edges here. Works the exact same way as the chamfer tool. Once you're done, it should look nice and symmetrical like this. Once we're done with our fillet tool, we're actually done with this sketch as a whole. So I'm going to go ahead and click Finish Sketch, as per usual. I'm going to, now we have our two sketches, so we can actually do something with this. So it does look nice to have this plane here, but I actually just want to get it out of my way, just because we don't really need it anymore. We've used it for what we needed it for. So now I have two sketches. I can finally actually use the Loft tool. Now, when you're lofting something, you typically want to start at the bottom and go up, or whatever you want your baseline sketch to be is the one you want to start with. So I'm going to start with the bottom quote-unquote sketch that I've got here, the one with the chamfered sides. I'm going to just select that. You'll see a little highlight as per usual Inventor behavior. And I'm just going to do the exact same thing with the top sketch, and you'll see it'll give me a nice preview of what this loft is going to look like. So you can sort of get the idea of what this tool does. It connects two shapes just with just with an angle, and it just creates a sort of nice smoothness between them. Now, it does look rather boring right now how these are like still straight edges. So if I wanted to make this a bit more curvy, a bit fancier looking, I can go up here, see, just keep in the Loft menu here, make sure you have everything I have selected here, keep it on rails, go to the conditions dialog box here up at the top, and you'll see we've got two sketches. So this was my sketch 1, is the bottom sketch, and my sketch 2 is the top sketch I have here with the fillets on it. So you'll see here in the dialog box there is a little option next to it with a drop down. You'll see it's currently under free condition. So that means it's basically free to move like however it wants to automatically. But if I were to select direction condition, you'll see that the angle and the weight numbers are no longer grayed out. That means I can actually edit these numbers. And you'll also see, once I have it under direction condition, that the curves on the box have actually changed. It's looking a bit nice now. Maybe our shape might be actually a little bit chubby. So like if I want to cut it down a little bit, let's say 70 degrees. And even if your preview doesn't update right away, your loft should actually work. Now see, it's looking a bit nicer. It's looking a bit more smooth. At first, it was a bit thicker towards the bottom here, but now it's more of an even trend along. So this is a pretty nice looking shape we have here. I'm pretty satisfied with it. Now, that is pretty much all you really need to know about the loft feature. You can actually do the loft with as many sketches as you want, and I encourage you to fool around with it because it can be pretty cool, and you can make some really interesting shapes. So like if I wanted to continue this box up, I could offset another plane up like 40 millimeters, and I could make another like even narrower box up here, and I could maybe with some edits, this could even look like the Eiffel Tower or something, you know? But that's not really it's not really a good focus for a video to just do the loft over and over again. So we're going to move on. Now the next tool I'd like to show you up here under the Create menu is called Emboss. Now basically an emboss is almost always a text sketch that you can either create an emboss from, which is basically raising text off of a surface, or you can make an engraving from, which I'm sure you're aware is when you etch something into the surface of a material. So we're going to be using that feature. As you can see here, it'll say we require a profile to do that. So a profile in this case, I'm just going to start a new sketch on the top face of our box, and I'm going to make some text. Let's say I wanted this to be my special box here. So I'm going to put my name on it. Look at that, Adrian. Bam. I'm going to turn that into 6.10 millimeter text because 3 millimeters is a bit small on our box. That's about, 90 to 140 millimeters wide. I'm just going to keep it on these settings for now. Just leave it on Tahoma text and stuff like that. I'm just going to click OK. And you'll see here, right down here, that we've created a text box, and it's a bit irregularly shaped. And for the most part, from my perspective here, it's on its side. So one thing we can do rather quickly is we can just use the Rotate tool here, select our text, give it an angle of 90 degrees, give it a center point, and just select the origin there, and click Done. Oh, I think I was supposed to hit Apply. Just do that again. Apply. Done. There we go. Bam. I've got it aligned properly. So that's how you rotate text. But you can see this box is still like, I don't know, I guess I made it much too long. So in this case, I'm just going to make a dimension, and you can actually edit the dimensions of your entire text box here. So let's say I wanted to make this 40 wide. Just give it some numbers. As long as you know the numbers of your box, you should be all right. So I'm going to exit out of the dimension tool here. I just made some dimensions to make this easier to work with. I'm going to double click on the text again, and in order to, let's say we want to center this. Let's say we want to center the text on this box. So if I know the numbers of all these edges already, I can just apply some dimensions, saying going from the sides of this box, say like the top of the text box to the top of our shape here. The same thing with the sides. But the text that's in the box is sort of like out of place, right? We can easily fix that by just making it center justified by clicking the middle justification and the center justification buttons up here. Click OK. It'll justify itself. Bam. So I know this shape is 90 wide, right? 90 millimeters. I've made the shape of, I don't know why it's all the way down here, but I've made the shape of my text box 40 millimeters wide. So just by some simple math, I can make this 25 and center it that way. And I can make this, oops. And I can make this, okay, what is it, 10 here? I know it's 80 high. That leaves me with 70 millimeters. So it'll be 35 millimeters on this. Bam. Centered. Looks nice, right? Now once we're done with our text here, we can just click Finish Sketch. And then you just go over to the Emboss tool, and it's really easy. You just click on your text. If you want to emboss it, you just leave it on Emboss from Face. If you want to engrave it, you'll go to Engrave from Face, and it'll just do everything for you. So let's say I wanted to emboss it. It'll raise the text up like this. Or if I wanted to engrave it, you just literally click on the feature again. You go back and you just select Engrave from Face instead. It'll go down inside like this. And this looks pretty nice. It makes it less choppy on the outside to do an engraving, so I'm going to keep it like this. Looks pretty good. So that's how you use the Emboss tool. Now the next thing I want to do is I just want to show you how to, let's say we wanted this box to actually be functional, you know, we wanted to hollow this out. Currently how Inventor has this done with the loft is inside this is just completely solid material. So what we're going to be doing is we're going to be using the shell tool in order to basically remove most of the interior material. But before we do that, I'm just going to make a simple slot in the side of this box just to get us some practice using some of the plane offsets. So I'm going to go under the plane tool here. I'm going to select offset from plane. We're going to make a new plane that we want to sketch on. So I'm going to make the slot sort of like, let me rotate here. I'm going to make it sort of coming out of the side of the box, coming out like maybe like here. So I'm going to make a plane on the YZ plane, offset it. What does 40 millimeters look like? Looks like exactly how I want it. So I'm going to keep it at 40. I'm going to start a new sketch on this plane. And now I want to make a bit more of an interesting shape here. I'm going to use the center to center slot tool. Let's make this 20 wide, and I'll give it a radius of 8. Now you can't see my sketch at the moment because it's kind of covered in material, but you can actually still dimension it. But if I wanted to actually work on this, you know, to dimension it a bit better, what I can actually do is I can, instead of making the extrusion come out from here, I can actually start the extrusion coming from the outside and going towards the part. So in order to do that, I can just go over to my work plane. Let's set this as 50 millimeters instead. See, now the slot is coming out, although that looks a bit too far out to me. So I'm going to go ahead and set this to maybe, oops. I'm going to go ahead and set this maybe 45 instead. And that looks a bit better. It looks a bit less obtrusive. So now I'm going to go back to my sketch. And now I'm going to start dimensioning this to other things. Let's give it a dimension in the vertical direction. How about 12 millimeters from the base? And we'll give it... Now we need some way to dimension it in this direction. Now, what I can actually do to use as a you can see I don't have a reference here. Or I could use that. I could use that. But let's say I didn't have this center point here. What I can do is I can actually, you see under the origin folder here on your model tree, I can actually go here and select one of these axes. Yeah, I can actually just select the axes directly, and it'll automatically come up and let me dimension down. So let's say I wanted to make this, I don't know, let's say 30. 30 for now. See? It looks good. Now that our sketch has turned to blue, that means our slot is now fully constrained. So I'm going to click Finish Sketch. I'm going to hide this nasty work plane, and I'm going to extrude our shape, not in this direction where it wants me to go, but rather in direction 2, going towards the part. Now I can use my extents here to go to next, and that'll make our shape go all the way into the lofted shape. There we go. We have our slot. Now, let's just say this slot will be used for, I don't know, picking up the box or like some sort of maybe threading cables in and outside of the box. Let's say there's some circuitry on the inside or something. I'm actually, before I do anything else, I'm just going to apply a quick fillet to this. Let's say maybe not 2 millimeters. Let's say, oh, 5 millimeters seems healthy, right? No, it doesn't. It doesn't seem healthy at all. So let's try maybe 3 millimeters. Okay. Now, before I do anything to this, I just want to, you know, this is a bit of an awkward transition here. So I'm going to change this to a fillet. Maybe instead of 5, I'll do 4 millimeters, and that doesn't want to do it. Alright, now before I do anything else to this box, I want to get rid of this sharp corners. I almost got ahead of myself here. I want to get rid of these sharp corners sort of between the edges of this slot and the base wall of our part. So I'm going to go up here under the Fillet tool for modifying 3D geometry. I use a radius 1 fillet, and I'm just going to select the inner edge here. It'll give me a nice preview. Just click OK, and bam, we're good to go. Now I can finally revisit the tool I wanted to show you guys in the first place, which is the shell tool. Now, the shell tool is one of the easiest 3D modifying tools in Inventor to use. You literally click it, right? It'll come up with this menu. You can select the wall thickness of your part. So let's say this part I wanted it to be like 3 millimeters. I can go ahead and type in 3 here. Whoa, my Inventor is crashing. Okay, now with the shell tool here, I'm just going to go up here. I'm going to select the shell tool. I can finally actually get into the rhythm of this. I'm going to keep my thickness here at 1 millimeters. And for my remove faces option, you can see that you can pretty much select any face on this part. I'm going to select this slot here on the inside. And you'll see it'll give me a nice preview of this slot showing the inside of the part. Go ahead and click OK. And it might be hard to see, but you can actually see the interior edges of this part, which is pretty cool. So now we know our part is actually hollow. And that's pretty much it for the shell tool. You can do this on any sort of 3D box as long as it's already an enclosed shape. Now let's say I wanted this box to be mounted on something. Let's say if this is a wiring box, I want this to actually be, you know, have some form of mounting to it. So if I wanted to put, let's say, screws or maybe nuts through this box in order to attach it onto something, I would have to put holes in the bottom of this box, right? It's very easy. So today I'm going to be using the hole tool, and I'm going to be automatically adding some tapped holes to it. So let's go ahead, and we're going to start with a 2D sketch here, and we're going to make 4 points with our sketch. 4 points using the point tool up here. I'm going to place them in 4 corners of this box. And now we're just going to be constraining them to all be equal to each other on these corners. So the first thing I want to do here actually is apply some vertical and horizontal constraints. So I want these two to be horizontally, oops, sorry, I was on the wrong one there. I want these two to be vertically constrained to each other. That meaning that they are on the same vertical level, right? I'm going to do the same thing with these two down here. I don't know if that actually got created or not. Now I'm going to do a horizontal constraint between these two, and they should be good to go. Let's see. So this has a vertical and a horizontal constraint. This just has a horizontal constraint, so my vertical one actually never went through. So here we go. Just going to vertical constrain those two. This guy's vertically constrained to this guy. This guy is vertically and horizontally constrained to this guy. This guy is vertically and horizontally constrained between these two. And this guy is vertically constrained between this guy. Now if we wanted, I believe we could actually also do this. But it might... Okay, yeah. No, we can. I was just wondering if that would actually over-constrain the part or not, but we're actually in the clear. Now we've got to start applying some numbers to these guys. So I can actually do this entire part by only typing in the numbers once. Now here's how I'm going to do it. I'm going to apply a dimension to this guy. Let's say we want it to be 10 out from the edge, 10 millimeters on both sides. Bam, I've typed in my numbers. I'm good to go for that. I'm good to go for that point, right? Now I want the same distances to be said for all these other points. Now there's a few different ways you could make this sort of symmetrical approach. You could always use like the mirroring tool in your sketch. You could just do this. You could have an axis down here. You could have an axis going across, and then you could just mirror this point onto all the other corners here. But in this case, I want to show you a bit about driven dimensions. And what a driven dimension is basically I'm going to create a dimension here. I'm going to put it out, click accept. Now, when we go to actually edit this dimension, so now that we have our numbers here, I want to show you a bit about how to make a driven dimension. It's going to be very simple. In order to make these all 10 millimeters from each edge, I can apply one more dimension to one of these points without having to go 10 here, 10 there, 10 there, 10 here, 10 here, you know? So what I'm going to do is I'm going to select this point. I'm going to select this edge. I'm going to make this dimension. Now, go ahead and edit the dimension. Erase whatever text is there. Now, if you've ever used Excel, this should be very similar to just how you relate different cells in Excel. So I'm going to go ahead and I'm going to click equals. And I'm going to select the dimension on the other side of the box that sort of reflects this one. I'm going to select the 10 millimeters here. You'll see it'll go D33 equals D33. So that this dimension that we're creating now, D36, becomes the same as D33 over here. Click the check mark. Bam. You see that this point moved down as well. You'll see that this is FX10, so now it's now related to this dimension. So that now, when this dimension changes, this one will change also. So I'll give you just a bit of a preview of that. So if I change this to 15, bam, they all move in. If I change this to 15, well, this one moves in, but these ones, did these ones move in as well? No, they didn't. So now we can figure out which dimensions we have to change here. So I'm going to change this one. I'm going to make it equals to this dimension up here, and you can basically do this until it looks all consistent. So now it should be actually fully constrained. Instead of making 8 dimensions here, I've only made 4. And you can see how this would be very, very useful if you have, let's say, 8 of these points, 10 of these points, or even way more than that. So if I can actually put this back to 10, bam, those all go back together, bam. They're all 10 away from the edges. Now we can click Finish Sketch. We're all good to go. So now, with my 4 holes, with my 4 points, I'm going to make holes. Now, when I select the hole tool, it'll actually use the last sketch I just made, so it's automatically selected some holes for us to use. Now you'll see that they're going all the way through our part at the moment, and that is less than ideal. So instead of our termination as through all, you'll sort of recognize this from the Extrude Tool. That's what we want to go to. We want to go to that face, right? To the inside bottom face of our part. You can sort of see it selected here with the dotted line. And you'll see that our hole only goes all the way through there. So if I wanted this hole to have a thread on it, which seems kind of ridiculous with a 1 millimeter thickness, but let's say I wanted it to have a thread on it, I would just go currently we have a simple hole selected, which is just an extruded hole basically. I could select tapped hole, and then you'll learn this probably not in first year, but probably second year, of all the different types of screws you can use. So if I wanted metric screws to be used on this, I'd go to ANSI M metric profile under types for the threads, and the size is just the millimeter width. So an M5 screw is 5 millimeters wide, like this. For a box like this, you would not need very hefty screws. Let's maybe make them like 3 millimeters. That looks pretty good, right? Yeah. So this is basically this is how you can make threaded holes in Inventor. It's very handy, especially because it gives you this nice little preview. You can sort of see it's got sort of painted on texture of what the thread will look like. There's no actual geometry here, but if you're like designing for automation with a CNC machine or something, this could be very interesting. It'll just automatically tap these holes. It'll recognize these as M3 holes, and it'll tap these holes with a drill. Now we finally have our final shape of our box. Now, how do I design this in a way that I can manufacture it, so that I can make it easily? Well, let's say my manufacturing process was through a 3D printer, right? Easiest form of manufacturing there is, of additive manufacturing, with a plastic part. So I can't really 3D print this box, right? It's a hollowed out box, just one singular shape. If I could get a really expensive 3D printer. I could print this, but the thing is, when it tries to print this top face here, it will have to fill this entire hollowed out portion with what's called support material that it builds up in order to actually build this model up here. And then it'll be nearly impossible to get the support material out. You'll have to put it in like a corrosive bath, and it becomes a huge hassle. So what if I wanted to split this part into two different parts? We'll call it, box bottom and box top. Well, there's actually a sort of simple way we can do this. So what I'm going to be doing is basically I'm going to be making an extrusion, but not the extrusion we're used to. Our extrusion is going to be a line through the middle here that will essentially cut our part in half without really cutting that part in half. We're going to use this extrusion, and then we're going to use a tool called push. And basically the push tool will just split these two different parts of our object into two different part files that we can use for 3D printing. So I'm just going to go ahead and start this here. I'm going to use the oh, sorry here. I'm going to make a line through the center here, just like this, through the center horizontally, from the position I have it at right now. So I want a plane leveled here, leveled through the center here. Actually, is what I want. I'm going to make an offset plane. I'm going to select YZ plane, and I'm going to move out. I'm going to have this profile move out like just so it's definitely past the edge of this box. So even 60 millimeters will do. Basically, I want the shape I make to cut all the way through this part. So I'm going to go ahead and start a sketch. And all I'm going to do is I'm going to draw a line that goes all the way through this part. I could even make it a bit cooler than that, right? You could even throw an arc in there. You can split this really however you want. Don't worry too much about how this line profile works. However, we do want it to be fully constrained, just like everything always is. So I'm going to apply some dimensions to this. Let's say I want it to go directly through the center of the box here. You can apply dimensions that you think are fit until it looks, you know, somewhat reasonable to the way you want it to look. Once you've got a nice sketch all smooth and cleaned up like this, all nice and blue, you can go ahead and click Finish Sketch. And what we can do is we're going to use the Extrude tool, and we're going to use it in a bit of a different way than what we're used to. We're going to extrude using this line, and you see that it's making this profile here. What we can do is we can actually, instead of making a flat profile, this doesn't have 3D geometry at all, right? We're just extruding a line in a direction. It's just an imaginary line with 0 thickness, right? 0 thickness. So basically what we can do is we can cut through our part using this profile and split it into 2. So what we're going to be doing, we're going to be using direction 2. And we're going to make it go through all. Bam. We have our extrusion. I'm going to get rid of this plane. Now we're going to be using the split feature to actually split this part in half, just as you can see here in the image. So we have our profile, and we're actually going to split this into technically 2 different solid bodies. Now we're going to click the lowest one called Split Solid. So we have a solid here, one solid body, and once we do that, you can see all the outer edges of the part get highlighted. That's exactly what we want. Once you have that, you just go ahead and click OK. It'll apply those changes. Now we have 2 solid bodies. It's really hard to actually visualize this, but if you go under the part model tree here, under solid bodies, you'll see that there will be solid 2, which is the bottom face, and solid 3, which is the top face. And once you're satisfied with your part, you can just go ahead and do a quick save as. Maybe name your part something like Master Enclosure or Full Part Top plus Bottom, whatever you like. Saved your part and given it a name, such as what I've done here called Master Enclosure.ipt. And we have our 2 solid bodies. What we want to do, let's say we wanted to split these into 2 different part files. So what we're going to do up here is we're going to go to Manage. And there's a lot of different features up here that you've probably never used before. What I'm going to be doing here is I'm going to click on Make Part. So basically, I've got 2 different solid bodies here, and I can make one of these bodies into its own separate part. So under the Solid Bodies tab here, I'm going to select Solid 2. And now be sure to uncheck the dialog box that says Place Part in Target Assembly. Part should now show up in a new design window, and now you can just go do the exact same thing for the second solid body here, and just name it Top, or whatever you really prefer. I now have my 2 separate parts, right? And if I wanted to, I could throw these in an assembly, and I could actually assemble these together and just show how they just kind of slide into each other, right? I've got my top, I've got my bottom. And basically now that I have my top and my bottom, I can actually print these parts separately, which was kind of the entire point. So I can print the bottom here so that it builds up, just builds these walls. And I don't really need any support material, just due to the overhang angle of the sides of the box here. And with my top, I can do the exact same thing. It'll just start printing out here with my emboss, and it'll print up and through here, up and through there, up through here, and I won't require really almost any support material, and it won't be too difficult to make. And basically at the end, you can always model some grooves in these if you wanted to if you want them to fit together like a nice cohesive one piece, or you could always glue them together or something else. But basically that's how you kind of design for manufacturing. Basically I would put both of these parts onto a 3D printer tray, and they would print up just from bottom up like this, and from bottom up like this. I can actually show you that in just a few minutes. Now if I want to 3D print these things, most 3D printing softwares don't actually accept Inventor's special file type, which is .ipt. So what I'm going to have to do is I'm going to go up to File, I'm going to have to go Save, or more likely Save As, and save a copy. and you want to save this as an STL file. And you can keep it as the exact same if you want. You can even you can go into the options, and once you get more comfortable with 3D printing, you can actually edit the resolution and stuff here, and it'll help you out with your prints to make them a bit cleaner. But for now, we'll just leave that alone, and we'll just change it to save type as STL, and you save it as that, and you'll do the same thing for the bottom. And then, once you're done, you should have files that are ready to 3D print. Once I have my STL files saved, I can actually go into this program, which I explained earlier, Ultimaker Cura, and go and find my files. And just under the folder I saved them as, you'll see that it'll recognize my files, bottom STL and top STL, and you should be able to place them in your software. And you can sort of rearrange them however you like. This one, we should be able to do it in one print if we can fit both files on here at the same time. So I placed my bottom, now I'll place my top, and I'll just rotate them however I need them, just like this. Essentially what I'm doing with this placement here is I'm making it as easy as a job as possible for the 3D printer to do. Almost all 3D printers prefer building wide over building tall. It'll make your print time much, much faster. And then you would select your slice settings. You'd probably just go to recommended. You can even give it support like this. Typically if you see red edges like this, it means they require support. But basically, how you take this to the 3D printer is you set up your printing tray like this. You click slice. It'll process your parts into a file type that the 3D printer can read, and you'll save it to a file. It'll give you a printing time. This is a long printing time, 7 hours just for this box. But you could always make some edits to the shell if you wanted to make these walls not as thick. You could, and that would reduce your printing time. It even shows you if you configure it for your 3D printer. It'll show you how much material it'll use, both in weight and in length of filament. And basically what you'll do is you'll save this file to a SD card. You'll take the SD card and you'll put it in the 3D printer, and you just select it from a list and it'll print. And that's basically all we have for today. My favorite one here is actually the Loft, because it really introduces a lot more easy approaches to designing some certain parts, especially anything with a curved edge or less than regular transitions. So anyways, I hope you enjoyed, I hope you learned something, and we'll see you next time. So I hope you learned a few things, mainly about designing for manufacturing, but I hope you also picked up a few new Inventor features that you didn't quite know how to use yet, such as the Loft Tool, or maybe even some versions of the Hole Tool, and even driven dimensions.